Joshua Smith made a comment on my video. He said, can you make a series on the tabs in EV3 and what you do with each block? So today I'm going to do the second video in the series, the orange tab or flow control. So this one is much shorter than the green one because it has less ones, but each one's more options, so I think the video will be about the same length. At the beginning, the first block in there is the start block. So this allows you to run multiple things at the same time. If I have two of these, I could say, let's spin motor A and motor B at the same time. Ta-da! Okay, now something important to note though is if we stick a weight here and we say, well, we'll just leave it as, well, okay, I'm going to talk about weights next, so actually not weight, but if we stick another motor block, it'll spin this motor block and this motor block at the same time, then this one, as you would expect, because they both start from the start at the same time. We can achieve the same result, however, by dragging from here and plugging it into that. Now that wired weirdly, but normally it works normal. And the benefit to doing it this way, rather than with an additional start block, is you can take it from wherever. So now these are running at the same time. They're running in parallel. Anyway, that's what the start block does. Then the next block is the wait block. This block waits. Sounds pretty obvious, but that's what it is. So you can determine what stops it waiting. While it's waiting, the only things that, while it's waiting, it doesn't send any new commands. It will refresh old ones, such as if you turn a motor on and then you put a wait, it will keep spinning this motor. So with the wait, however, in the bottom left, that little tab that almost every single block has, gives a whole bunch of options. And all these options are what are we going to wait until. Brick buttons, till a certain brick button is pressed or till the brick button state changes. Color sensor, till the color reflected light intensity or ambient light intensity reaches a certain value, or the color reflected light intensity, ambient light intensity values change. Gyro sensor, same thing, compare change. Infrared sensor, same thing, compare change. Motor rotation, same thing, compare change. Temperature sensor, same thing, compare change. Timer, same thing, compare change. Touch sensor, same thing, compare change. With different things at the end. They're all pretty much the same. The only one that's different is messaging, which is compare update change, and time, which is just time. Now, if you don't have all of these options when you click on the thing, or you have different ones, that's okay. I have the student edition education. I have the education student edition. I said that weird. Most of the time you'll get the retail edition. Both are available for free online. I personally prefer the education one, so I got the education one. You could have something that looks slightly differently. The way you can tell is if on the home screen it has pictures of robots, it's the retail edition. If it looks similar to this, it's the education edition. So if mine looks slightly different than yours, don't freak out, it's fine. So all of these are basically the same. So if we were going to say wait for 2 seconds, this waits, and this is the amount of seconds. So wait for 2 seconds. So if we were to start this program and run it right now, it would run, do nothing for 2 seconds, and then end the program. A very exciting program for sure. But if we were to say color sensor compare color, then we could say when not red, but when it's not brown, I wanted black. When the color sensor in port 3 sees black in the program, or go to the next block. So what happened right now is it would run, it would wait and do nothing until it's all black. But this is how we make a very simple drive to align. Presto. What this will do, it'll turn both the motors on. Then it will keep them going on, waiting until this color sensor sees black. Then it will turn them both off. What this will do is this will drive until the color sensor sees the black line, and that allows you to find lines on an FLL mat. The next, you can also do that with any of these other things, not just color sensor, but say ultrasonic sensor or touch sensor or timer and time. Okay, I'm going to touch on this in the next video, but there is a distinction, and I'll touch on what that is in the next video. But then the next one, the next block in the series is the loop block. What this block is everything inside of this repetition bit repeats until this condition right here, that's the in condition, is met. So this condition, again, can be specified to anything and a couple more. So this has 3 more than the wait. The 3 more it has is unlimited, which means it will repeat for forever until you stop the program. Count, which means it will repeat a certain number of times. And logic, which means it will repeat until you pass in the input of true or you pass in the input of false. No, sorry, until you pass in the input of true. What am I saying? All the rest of them, they're the same, except it doesn't have the compare or change. It just has the compare option, which personally I like more than the change. But so it just has the compare, but otherwise it's exactly the same. And a handy feature about the loop is you can get data out of it. So if you have, here I'm just going to create one beside it to show you. So the difference between what I'm making and what I'm about to make, actually that doesn't help you much, so I've made it. So this was what I showed you earlier for a drive to align. And we can do the exact same thing by saying, we're doing the exact same thing here. Nothing is actually different. So if we were just run both of these, they would do the exact same thing. So a question that is kind of the first one that pops into your brain is, well, why is the loop any better then? And the loop is better because it allows you to do alterations and get out data. So we have this lovely display block, right? If, let's say we wanted to, actually I should touch on this later, but let's say we wanted to display, let's say we wanted to display, and I'm going to drag a block up from the yellow tab. I'll talk more about the yellow tab in the next video. So let's say we wanted to see what color it thought it saw, because it wasn't stopping where we thought it should see for black. So we can drag up a color sensor block and drag the wire, and now it will keep driving and it will continuously update the screen with what color it's seeing, which is very, very cool. Okay, I'm going to get rid of it all. Okay, and then the next block in the row is the switch. This is another thing a loop is good for. You've got a loop, and you have a switch. And what will happen is the loop will continuously go through the switch. So what the switch does is it makes a decision. It splits the path. So the default is if the touch sensor is pressed, if the touch sensor from port 1 is pressed, so if what is in here is true, it will run the check box. If what is in here is false, it will run the X box. No, not the X box like the gaming system. The box with the X in it. So what this lets us do is, let's say we wanted to build an annoying program. And it would, whenever you press the touch sensor, it would play a sound. And whenever you weren't touching the touch sensor, it would stop all sounds that were currently playing. And we're going to change this from wait for completion to play once, just so that it will actually do what we're telling it to do. So now you hold it down, it'll make an awful noise, you let go, it'll stop. It's amazing. And it will continue over and over. Whereas without the loop, if we just drag the switch up, it'll check it once. So you run it. If in that split second after you run it, you're holding down the touch sensor, it'll beep. Otherwise, it'll stop all sound, and then it will end the program. That's not half as exciting as when it's inside of a loop, and you can just continually press it for as long as you want. Now, something that we could do that's interesting is right here, out of this comes how many times through the loop it's been. So let's say instead we wanted to play a tone. Never mind, let's not do that. So we can take this and plug it into whatever we want. So the switch block also has other choices, such as brick buttons, color sensor, same thing as the weight, except it also has logic, which true or false, and numeric, which is what number. Now, if we plug this in, what will happen is the first time through the loop, it'll run this. No, sorry, the 0th time through the loop, it'll run this. The first time through the loop, it'll run this. And there should be a little plus box somewhere. Ah, here it is. And here we can add a case. So, second time through the loop, it'll run what's in here. The third time through the loop, it'll run what's in there. Pretty cool. But those loops are happening like much faster than I could snap, so that's not even a good representation, but they're going very, very fast. Computers are fast, humans are slow. So you might want, if you were actually going to do something like this, you'd apply a dampening factor or something like that to make it more reasonable where you could actually hear this before it just immediately stopped. Another thing that's interesting about switches is up here in this top left, something called switch to tabbed view. What this does is this, instead of having it where you can see it all at once, which is flat view, it collapses it to tabbed view. And what this lets you do is it lets you have it much more compact, because you can add more cases and it doesn't actually get bigger. It just adds more. And an additional thing about tab view is you can drag data wires in. Flat view, you can't. Tab view, you can. So see, then we could do whatever we wanted in here, whereas if we had it in flat view, data wires cannot enter or leave a switch in flat view. All such wires will be removed. This will change the behavior of your program. Isn't that interesting? I don't know why they chose to do that. Just something I thought I'd mention. The last block in here is the loop interrupt. I'm just going to touch on this briefly. It is typically pretty dangerous, so if you're going to use it, make sure you were listening to the section and don't just accidentally mess it up. So, if you have a loop, here, I'm going to drag this out. It has a name. This right up here is its name. You can name whatever you want. You can name it whatever you want. You can type in text in there, but typically it's a good idea to either leave it as 01 if you don't want to interrupt it, or name it something if you do want to interrupt it, and name it something meaningful. So let's call this test case. Okay? So now, in our loop interrupt, we can choose that we want it to interrupt test case. So, what will happen is it'll go through, it'll go do, it'll come through the first time, it'll interrupt test case, and it'll come out here, even though we have it unlimited. So, what this also allows us to do is this allows us to say, continually make a noise. Continually make a noise unless we press the touch sensor. If we press the touch sensor, interrupt the loop. Now, the reason why I said this is dangerous is if you have multiple loops. Let's say you had a my block that had a loop in it, or you just have a loop, and you have them both named 01. So let's say that it does something prevalent after that first loop, like it displays something. Let's make it display a circle. Lovely circles. So now what will happen is it'll come through, we'll run this, it'll check. It'll infinitely make the noise until we hit this button, then it will interrupt all the loops with the name 0, 1. So where's that going to bring us? Right here. Whatever block is here, which, theoretically, if we put a block here, this is infinite. Nothing after here should run. That's just stupid. Why would you put any block there? So what that means is the program will end. But if you accidentally mess up and have the interrupt 01, and it cuts all these, it cuts all them. So always, I'm going to stress this really hard, always, 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 when you use the loop interrupt, name your loop. If you don't use the loop interrupt to interrupt that loop, it's fine to leave it 0, 1. Almost 100%, so probably 98% of my team's loops this past year were named 0, 1. There were about maybe 5 or 7 loops that were named something different because we didn't want them to be accidentally interrupted or we wanted to intentionally interrupt them. And that's really the only reason why you should bother changing the name, because anything else you hope to gain from changing the name, you can just gain by putting a comment above it that says, this loop, this loop is our master, or whatever else, right? If you were to name this master, these comment and this name is the same thing. So, in my opinion, there really is no reason to name your loop unless you're interrupting it. But if you're interrupting it, name your loop.